Hi, let's continue with our class, and in this video I will introduce to you the classification. So similar to the regression algorithm, classification also learns from the dependent or target variables and uses all the predictors or independent variables to find the drive pattern. The major difference comes from the idea that in classification, the target variable is categorical, whereas in regression, it's in numeric. And in this video, we'll introduce logistic regression to demonstrate the concept using the Beijing PM 2.5 dataset. So let's talk about logistic regression. So logistic regression is the most favorable white box model used for binary classification. White box models are defined as the models providing visibility into the entire reasoning done for prediction. So for each prediction make, we can leverage the model's mathematical equation and decode the reason for the prediction made. There are also a set of classification models that are entirely flexible, and that is by no means we can understand the reasoning for the prediction leveraged by the model. So in situations where we want to focus only on the end outcome, we should prefer flexible model as they are more powerful. So through the name and switch regression, logistic regression is a technique used to predict the binary categorical outcomes and is hence a good choice for classification problems. As discussed in the previous video, we need a different approach to model for a categorical outcome. This can be done by transforming the outcome into the log of the odds ratio or probability of the event to happen. So now let's distill this approach into a simpler constructor. So assume that the probability of success for an event is 0.7. Then the probability of failure for the same event would be defined as 1 minus 0.7 equal to 0.3. The odds of success are defined as the ratio of the probability of success to the probability of failure. So the odds of success would be 0.7 divided by 0.3 equal to 0.33. That is the odds of success are 2 to 1. So if the probability of success is 0.5, that is 50% to 50% chance the odds of success are 1 to 1. So the logistic regression model can be mathematically represented as follows. So we got, as you can see, we got ln, which is log e. So it can be wrote as log e. So we got p is a probability of success, and 1 minus p is a probability of failure. So we got delta 0 plus delta 1, and then we got until beta n times xn. So here we got ln p divided by 1 minus p is the log of the odds ratio, which is called the logistic function. So solving the math further, we can deduce the probability of the outcome as shown below. So as you can see, we got p equal e to power p0 plus p1x1 p2x2 and until bn xn, and we got 1 plus e to power of p0 plus p1 x1 p2 x2 and until beta n xn. So discussing the mathematical background and derivation of the equation is beyond the scope of this video. So however, to summarize, the logistic function, which is the link function or logic function, has the logistic reframe the problem predicted outcome intuitively as the log of the odds ratio. So this when solved helps us to predict the probability of a binary dependent variable. So let's talk about the mechanics of the logistic regression. So just like the linear regression where beta coefficients for the variables are estimated using the OLS method, So the logistic regression model leverage the maximum likelihood estimate, which is MLE method. So the MLE method estimates the best set of values of the model parameters of beta coefficients such that it maximizes the likelihood function that is the probability estimates. It can also be defined as the agreement of the selected model with the observed data. So when the best set of parameter value is estimated, plugging these values beta coefficient into the model equation as defined earlier, helping in estimating the probability of the outcome for a given sample. Akin to OLS, MLA is an iterative process. So it's a good time to talk about building the model. So like linear regression for building a logistic regression model in R, we have the GLM generalized linear model method to fit the data and logis function to score the observation. So the syntax using the GLM function as follows. So we got GLM and then x1 plus x2 plus x3 and then we got the data equal trend data and family equal binomial link logic. So here y is our dependent variable and x1, x2, x3 are the independent variables. The argument data will take the training data set, so the familiar argument is set to binomial, which is the link equal logis, which fits a logistic regression model. And that is all in this video, so I hope you enjoy it and I will see you in the next video.